students, I hope all of you are doing good. Let's start today's chapter, squares and square roots. After reading this chapter, you will be able to know about all these topics. Okay, so let's start first with squares. When a number is multiplied by itself, the product obtained is called square of the number. For example, if we multiply 7 by 7, so we'll get 49. So 49 is called the square of 7 and written as 7 square. Okay, similarly, 15 into 15 is equals to 225. Means 225 is the square of 15, right? Perfect square. The numbers 1, 4, 9, 16, 25, 36, etc. are the squares of natural numbers, that is 1, 2, 3, 4, 5, 6 respectively, and are called perfect square numbers. To test whether a given number is a perfect square or not, we find its prime factors. If these prime factors can be expressed in pairs of equal factors, the given number is a perfect square. For example, 729. We have to find out whether it's a perfect square or not. Okay. And if so, if it is, then find out the number whose square is 729. Okay. So first we will find out prime factors of 729. Okay. 3 2s are 6, 3 4s are 12, 3 3s are 9. And 2 3s. 81, 3, 27, 3, 9, 3 3s are 9 and 3 1s are 3. Okay. So, prime factors of 729. 3 into 3 into 3 into 3 into 3 into 3. Okay. 1 pair, 2 pair, 3 pair. Okay. So, this is forming a pair, that means it's a perfect square. And now we have to find out whose square is a 729. Okay. So, 3 into 3 into 3. 3 3s are 9, 9 3s are 27. Okay. So, this is the square of 27. Okay. Example 2, show that 123 is not a perfect square. Okay. First, we will find out the prime factors, and prime factors are given here. You can see a pair, this number is not making any pair. So, this is not a perfect square. Okay. Let's do exercise 6.1. Using the prime factorization method, find which of the following numbers are perfect squares. Okay. First, 768. Okay, since it's an even number, so we'll start with 2. 2 3s are 6, 2 8s are 16, 2 4s are 8. 2 1s are 2, 2 9s are 18, 2 2s are 4. 2 9s are 18, 2 6 are 12. 2 4s are 8, 2 8s are 16. 2 2s are 4, 2 4s are 8. 2 12s, then 2 6 and 2 3s are 6, then 3 1s are 3. Okay, let's make the pair 2 3. Okay, but we are unable to make pair of 3. That means it is not a perfect square. Okay, so similarly you will do other parts also. Okay. Properties of perfect square numbers. Property 1. We write the squares of first 10 natural numbers. Okay. So, these are the squares of first 10 natural numbers. It is observed that these perfect squares end in 0, 1, 4, 5, 6 and 9. None of the square ends in 2, 3, 7 or 8. As you can see here, none of them ends at 2, 3, 7 and 8. So, to test whether a given number can be a perfect square, look at the unit place a digit. If it is one of the digits, 2, 3, 7 or 8, the given number cannot be a perfect square. Okay, for example, 227. 7 is at unit place, 482. 2 is at unit place, 723. 3 is at unit place, means these numbers are not perfect square. Okay, but if a number ends with 0, 1, 4, 5, 6 and 9, it may or may not be a perfect square. For example, 91, 125 and 69 etc. are not perfect square numbers, though they end in 1, 5 and 7. Okay. Property 2. Write the square of even and odd natural numbers. Okay. So, here are square, these are the square of even numbers and these are the square of odd numbers. It is observed that squares of even numbers are always even and squares of odd numbers are always odd. Right? Property 3. The number of zeros at the end of a perfect square is always even. For example, 100, in this case, we have 2 zeros, it is square of 10. 900, it is square of 30. And 3,60,000 is square of 600. Our perfect squares, the number of zeros are even. Okay, number of zeros should be even. Okay, whereas 10, 450 and 1000, these are not perfect square because number of zeros are odd. 1, 1, 1, 2, 3, odd, right? Property 4. For every natural number n plus 1 square minus n square is equals to n plus 1 plus n. That is, difference between squares of two consecutive natural numbers is always equal to their sum. Okay, for example, 16 square minus 15 square we have to find. So first we will find their sum. 16 plus 15 is 31, and the difference of their square, that is 256 minus 225, is 31. Okay. Property 5. Adding triangular numbers. Some of the triangular number are as under. See, 1, 3, 6, 10, right? Reason for these results. Okay. 1 plus 3 is equals to 2 square. 3 plus 6 is equals to 3 square, that is 9. Similarly, 6 plus 10 is equals to 4 square, 16. Here 10 plus, let's count these dots, circles, 5, 9, 12, 13, 14, 15. So, you will get here 15. 10 plus 15 is 25, that means it is a square of 5. Okay. Similarly, these 15 plus, count all these dots, circles, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So, 15 plus 21 is 36, which is a square of 6. Okay. If we add two consecutive triangular numbers, two consecutive triangular numbers, okay, like 1 plus 3 is equals to 4, it is square of 2. Then 3 plus 6 is equals to 9, square of 3, right? Then 6 plus 10 is equals to 16, square of 4, etc. We get to square numbers. Try adding consecutive triangular numbers and verify the property. Property number 6. Numbers between two square numbers. Okay. See, two consecutive square numbers, n square and n plus 1 square. Okay. See, 1 square and 2 square, that is 1 and 4. 2 square and 3 square, 4 and 9. 3 square and 4 square is equals to 9 and 16. 4 square and 5 square, that is 16 and 25. Okay. Similarly, 5 square, 6 square is 25 and 36. So, n square and n plus 1 square. Okay. Natural numbers between n square and n plus 1 square are given here. Okay. So, what is the hidden rule of number of natural numbers between two consecutive square number? 2 into 1 is 2, 2 into 4, 2 into 3 is 6, 2 into 4 is 8, 2 into 5 is 10, then 2 into n is 2n. Okay. We find that between n square and n plus 1 square there are 2n numbers, which is 1 less than the difference of 2 squares. Thus, there are 2 n non-perfect square numbers between the squares of the numbers n and n plus 1. That is, if n is equals to 2, n plus 1 is equals to 3. n plus 1 square minus n square is equals to 3 square minus 2 square is equals to 9 minus 4 is equals to 5. 1 less than 5 is 5 minus 1 is equals to 4. So, between 4 and 9 there are 4 numbers, they are 5, 6, 7 and 8 non-square numbers, right? Try to find numbers between 16 square and 17 square and 21 square and 22 square and verify. Property 7. Adding odd natural numbers. See this, 1 is equals to 1 square, then 1 plus 3 is equals to 4, that is square of 2, then 1 plus 3 plus 5 is equals to 9, that is square of 3. So, we say that sum of first n odd natural number is equals to n square, means 1 plus 3 plus 5. How many odd numbers we have added? 1, 2, 3. That means this is the square of 3, that is 9. And if you add them up, 1 plus 3 is 4, 4 plus 5 is 9. Okay. Property 8. Product of two consecutive odd or even natural numbers. Okay. Two consecutive odd or even natural. Okay. Two consecutive odd, 13 into 15 is equals to 195. Okay. So, this is what? 14 square minus 1. 196 minus 1 is 195. Okay. Similarly, two consecutive even numbers, 16 to 8 is 48, which is 7 square minus 1, that is 49 minus 1 is equals to 48. So, in general we can say that a plus 1, a minus 1 is equals to a square minus 1. Here a is a natural number. Okay. Exercise 6.2. The following numbers are not perfect squares. Give reasons. Okay. First one is 2, 3, 6, 7, 0. Okay. Zeros are not in even numbers. That's why it is not a perfect square. Similarly, the reason for second part is the same. Okay. Square roots of perfect squares by the method of long division. We have learned the method of finding the square root of perfect squares by prime factorization. When the square numbers are very large, the method of finding their square roots by prime factorization becomes very lengthy and difficult also. Sometimes it is not a perfect square. In such cases, we use the method of long division to find the square root. We follow the following stepwise procedure to find the square root of numbers by long division method. Procedure. Step 1. Obtain the number whose square root is to be computed. Step 2. Place bars over every pair of digits starting with the units digit. Also, place a bar on the one digit, if any, not forming a pair on the extreme left. Step 3. Think of the largest number whose square is less than or equal to the first pair from left. Take this number as a divisor in the quotient. Step 4. Put the quotient above the pair and write the product of divisor and quotient just below the first pair from left. Step 5. Subtract the product of divisor and quotient from the first pair and bring down the next pair to the right of the remainder. This becomes the new dividend. Okay. Step 6. Add the recent quotient obtained to divisor as it appears and enter it with a blank on the right for the next digit as the next possible divisor. Step 7. Think of a digit to fill the blank in step 6 in such a way that the product of new divisor and this digit is equal to or just less than the new dividend obtained in the step 5. Step 8. Subtract the product of the digit chosen in step 7 and the new divisor from the dividend obtained in step 5 and bring down the next pair to the right of the remainder. Step 9. Repeat steps 6, 7 and 8 till all the pairs have been taken up. And step 10. Obtain the quotient as the square root of the given number. Okay. Always remember, mark of the digit in pairs from right to left. Okay. Not from left to right. Is it clear? So, let's do example 5. Find the square root of 17424. 17424. First, we will make pairs starting from right. Okay, one pair, two pair, and this is single. 17424. Okay. So 1 ones are 1. Then we will bring down 74. We will add these two numbers. 1 plus 1 is 2. Okay. Now 20. Make sure number here and here should be same. 3. 3 3s are 9. 3 2s are 6. Okay. So remainder is 5. Now we will bring down 24. Now 23 will add 3. We'll add 23 with 23. So 3 plus 23 is what? 26. Okay. Now 2. 2 2s are 4. 2 6 are 12. 1 carry. 2 2s are 4 and 5. Okay. Now 132 is the square root of this number. Okay. So we will write, this is the symbol of a square root. Okay. Similarly, you will find the square root of this number also. Okay. In example 7 also you have to find out the square root of these numbers. Okay. So let's find out 390625. Let's make the pair. Okay. So first 6 6 are 36. 306. Okay. 6 plus 6 is 2. Then 2. 2 2s are 4. 2 2s are 4. Then 2 2s are 4 and 2 2s are 1. 2. 10 minus 4 is a 6. Then 2. Okay. 122 plus 2 is 124. Okay. At units place there is 5. So that means here also 5 should come. 5 5s are 25, 2 carry, 5 2s are 20, plus 2, 22. again 2 carry, 5 2s are 10 plus 2 12 and 5 1s are 4, 5 plus 1 6. Okay, so 625 is the answer, right? Remember, never take a negative sign inside the sign of square root. Okay, under root minus 4 is imaginary quantity. Okay, and no more. In division method, we predetermine the number of digits in square root. Okay, see, number 10 square is 100, smallest 3 digit perfect square. 31 is 961, largest 3 digit perfect square. Okay, so similarly, go through this. Conclusion, if 3 or 4 digits are here in a number, then square root will have 2 digits. If 5 or 6 digits are there in a, then square root will have 3 digits, right? And this one, if perfect square is of n digits, then if n is even, then square root will have n by 2 digits. B, if n is odd number, then square root will have n plus 1 by 2 digits, right? Let's do exercise 6.3. We have to find out the square root of the following by long division method. 1 2 5 4 4. Let's make the pair. Okay, 1 1s are 1, only bring down 2 5 down, 1 plus 1 is 2, 21s are 21, 4, and we'll bring down 21 plus 1, 22, okay, then 2, 4 4 4, okay. So the square root of this number is what? 112, right? Square root of numbers in decimal form method, make the number of decimal places even by affixing a 0 if necessary. Now mark off the pairs after decimal from left to right and extract the square roots as shown below. Okay, let's see example. Find the square root of 0.56423. Okay, so we will put 1 0 here, 1 2 3. There are how many pairs? 3 pairs. Okay, now we will take a 5 6 verse. So first we'll put a decimal. 7 7s are 49. Okay, 16 minus 9 is 7, then 4 2. 7 plus 7 is 14, then 5. 5 5s are 25, 2 carry, 5 4s are 20, plus 2 22, 2 carry, 5 1s are 5, plus 2 7, 7 25. 12 minus 5 is 7, 3 minus 2 is 1. Okay, now we will bring down 30. 145 plus 5 is 150. Okay, then 1, 1501. See, 10 minus 1 is 9, 2 and 2, 229. Okay, now what will we do? Add 2 more zeros, okay, here, or if not, we can write here 2 zeros. Okay, so 1501 plus 1 is 1502, and here what will you do? You will add 2 more zeros. Okay, now 15021. Okay, 9 minus 2 is 7, 8, and 12 minus 5 is what? 7, 7 8 7 9. Okay, so this is the square root of this number. Okay, remember, make pairs carefully. Before decimal, right to left like this. After decimal, left to right. Okay, and if after decimal number of digits are odd, then add a 0 in the leftmost place. Example, 72.931 will be 72.9310. And B, if it is asked to find answer up to 2 or 3 decimal places, we put more zeros in right side. Example, 217.34 will be 217.340000, right? Similarly, you will find out, you will do these examples, you will find out the square root of these decimal numbers. Okay. Now let's do exercise 6.4. Fill in the blanks. 0.16. Square root of this is 0.4. and square root of 0.25 is 0.5. Okay students, I hope you have understood this chapter, and now you will do practice of this chapter.